Okay, so today's this lesson we're going to talk about a double angle formula. For the previous lesson we have talked about the compound angle formula, and now we can further derive more formula related to trigonometry. Alright, so we're going to start from the first one. Okay, so the double angle formula means like you have a double amount of angles. So if we have like sine 2 theta, then the formula tells you it is equal to 2 times by sine theta cosine theta. That is the formula. You don't need to prove it to use the formula in the exam. You can just use it. All right, it is always true no matter what the theta equals to. All right, so how do we prove it? All right, what's the reason behind? So let me just prove it for you. Let me just pick a good color for proving. Right, so how do we prove this? Now, we know from the compound angle formula, so if we're starting from the compound angle formula, it will be sine alpha plus beta. We're going to get sine alpha cosine beta plus cosine alpha and then sine beta. And in that case, if alpha is equal to beta, then we have a double amount of angle. So what we can do is we can let alpha equals to beta. So therefore, we are going to get sine alpha and then cosine alpha plus cosine alpha sine alpha. Imagine if we just treat everything in terms of alpha. All right, so that gives you 2 times by sine alpha cosine alpha, which is equivalent to the previous one we had before. And then what we are going to do is just simply replace the beta with alpha. So we're going to get sine alpha plus alpha, which is equal to sine 2 alpha. All right, so that's how you prove it. And that is the double angle formula for sine. Okay, so what is the double angle formula for cosine and tangent? If we just follow the same proof, we are going to get the double angle formula for cosine. All right, so cosine 2 theta is equal to cosine square theta minus sine square theta. So that's the double angle formula for cosine. Now, the proof is just going to be the same. All right, it's the same proof here, which I'm going to prove it for you again. So if we're starting from cosine alpha plus beta, we're going to get cosine alpha cosine beta minus sine alpha sine beta. So that gives you, the cosine alpha cosine beta minus sine alpha sine beta. But if we let alpha equals to beta, so we're changing that alpha plus beta to 2 alpha, then let's see what happens, okay? So we're going to get cosine alpha minus sine alpha, and then sine alpha here. So that's why we'll have a square, so cosine square alpha minus sine square alpha, which is equal to cosine 2 alpha. All right, now the question is, do we have another formula for the double angle formula for cosine? Yes, we do. Actually, for the double angle formula for cosine and 2 theta, you have 3 of them. And the one I just showed you right now is the one I feel like it's most useless one. Okay, so I don't really use that one so often. All right, so I'll use the other 2. All right, now from the previous trig identities that you have learned, we know that the trig identity formula, which is the Pythagorean identity, the Pythagorean identity tells you that sine square theta plus cosine square theta equals to 1. So from here, what I can do is making sine square alpha as a subject. So we're going to get 1 minus cosine square alpha. And then we can get cosine square alpha as a subject. We're going to get 1 minus sine square alpha. Alright, so then from the previous cosine square formula here, so double angle formula for cosine 2 theta is equal to cosine square theta minus sine square theta. Then what we can do is we can start to do replacing the cosine square alpha or theta by 1 minus sine square theta, and then replace the sine square theta by 1 minus cosine square theta. So let's just replace this part here first. All right, let's just do a substitution inside and see what happens. So that gives you cosine square theta minus bracket 1 minus cosine square theta which is equal to cosine squared theta minus 1 plus 2 cosine squared theta, which again, that gives you 2 cosine squared theta minus 1. So that becomes another form. So the expansion of cosine 2 theta now can be combined with Pythagorean identity to give you another form of this expansion, all right, which is more useful than the previous form. All right, so now cosine square 2 theta, let's just prove the other one. All right, so instead of replacing the sine squared theta, this time I'm going to replace the cosine squared theta, okay, into here. So if we replace that, let's see what we have. All right, we're going to have 1 minus sine squared theta minus sine squared theta, and that gives you 1 minus 2 sine squared theta. All right, so that becomes the double angle formula for cosine 2 theta. You have 3, okay? You have 3 expressions, all right? 3 different forms. So let me just write this one here. So you have the first one is the more general one, which is cosine squared theta minus sine squared theta. And then you have the one that's only in terms of cosine, which is 2 cosine squared theta minus 1. And the last one is 1 minus 2 sine squared theta. Right. Most of the questions, or I would say majority of the questions, are using these 2 forms to prove it, to either show trig identities, or you're going to use this one to solve equations. It's really rare to use this form, okay? So I guess the first thing you need to think about the double angle formula for cosine is always these 2 forms. Alright, I just feel like you have more questions related to these 2 forms because you have to choose the right one to use so you can do the question, right? In the future lessons, I will let you know when or, are you going to use which form and what is the key that can help you, or is there any hint in the question that can help you to sort of know which formula that you're going to use. Alright, so the next one is the tangent double angle formula. Alright, so we've done the sine 2 theta, cosine 2 theta. Now let's move on to the tangent 2 theta. Well, luckily for tangent 2 theta, there's only one form of a formula. So that gives you 2 tangent theta over 1 minus tangent square theta. Now that's pretty easy to prove. Alright, it's just using the compound angle formula before. Alright, because we know that tangent alpha plus beta is equal to tangent alpha plus tangent beta, and divided by 1 minus tangent alpha tangent beta. So in that case, if we just let alpha equals to beta here, so then we're going to get tangent alpha plus tangent alpha over 1 minus tangent alpha times by tangent alpha. And that gives you 2 tangent alpha over 1 minus tangent square alpha. Alright, and then that gives you tangent 2 alpha. That's how you prove it. Alright, so those are the 3 double angle formula, one for sine, one for cosine, one for tangent. Alright, now what type of question you're going to get for the double angle formula? There's so many questions that you can get. The first type of question is the trig identities. Like you have to prove the trig trigonometry identities. So I'm going to show you a couple of examples. Like the type of question you're going to get using those 3 different formulas here. So the first one is trig identity formula. Like how do we use a trig identity formula to prove trig identity questions? All right, so the first one I'd like to do is maybe just do this one here. Tangent prove tangent 2x cotangent x is equal to 1 plus sec 2x. So here's the question. Where do we start? Do we start from the left hand side or do we start from the right hand side? Usually it doesn't really matter, alright? Depends on how hard of each side. For this question here, I would like to start from the left hand side. Alright, so let's do it. So let's start from the left hand side. That becomes tangent 2x cotangent x. Alright, now the first step what I'd like to do is probably, as you can see, that's a double angle, which is 2x. So I'd like to use the double angle formula here. I'm not really sure what, the value I'm going to get, but that's sort of like the only things I can do right now. So let's use it. Alright, next. I would like to change that cotangent x into 1 over tangent. 1 over tangent x. I just feel like it's just easier if I change into here. It will be easier for us to do the question. Hopefully, it's easier. All right, so now what you can see here is we have 1 over tangent times by the chunk of stuff like in the front. What we can do now is we can cross these two out. All right, so we're going to get 2 over 1 minus tangent square x. All right, so now our job is to find a way to prove this part is equal to the right hand side there. All right, we're going to find a method to prove it. Obviously, it's not going to be that easy. All right, so you're going to find a way to do it. So sometimes when you prove trig identity question, you do have to try a few things and to see if this match with the question. All right. So what we now want to do is really have a look at the right hand side. You have 1 plus sec 2x. And then if you think about how to do this question here, sec 2x is 1 over cosine 2x, right? All right, okay. And then that becomes cosine 2x plus 1 over cosine 2x. All right, so your job is sort of like, you're going to change from here to there, right? Quite a different, format, because one is in terms of a tangent, the other one is in terms of cosine 2x, sort of totally different. So how would you do that? Okay, that's the question. Now, the idea behind here is start to think about why there's a 2 here and how do I get rid of the 2? That's the problem, okay? Now, do you remember previously I said to you guys, for the trig cosine 2x question, all right, you have 3 different ones you can use to prove it, all right? The first one is cosine square x minus sine square x. And then the next one is 2 cosine square x minus 1. And the last one is 1 minus 2 sine square x, right? Now you're going to find a way to think about, which formula to use. And that is always the problem. That was always the harder one to think about. How do we know which one to use? All right. Now I want to like you to pay attention again to the numerator. The numerator is equal to 2. All right. It is equal to 2. You need to think about how do we get a numerator equals to 2. All right. Which formula should I use so the numerator is equal to 2? And then we can think about how do we deal with the denominator. So usually what you need to do is try, all right, and then see what happens. All right, most of the time you're probably not going to get an answer, but you're going to try until you figure out, oh, that's the right way to do. Okay, all right. What I want to do is I am going to use this part cosine 2x, and I'm going to use that formula here, that one there, to replace it. All right, you'll see what happens. Let me just show you. All right, so that gives you should be cosine, right? So there'll be 2 cosine square x minus 1 plus 1. And the denominator, this time I'm going to use a different, double angle formula for cosine. So I'm going to use cosine square x minus sine square x. By doing that, you can see you get 2 cosine square x over cosine square x minus sine square x. All right, now if we divide every single term, all right, by cosine square x, it's like, we divide both the top and the bottom by cosine square x over cosine square x. Then we're going to get 2 over 1 minus sine square x divided by cosine square x is tangent square x. Here we go. That becomes our answer. All right. So this is the idea. But obviously, I don't recommend you use this method to work out the answer. All right. Because as you can see, you're starting from the left-hand side. You worked to one part, and then you stopped, and you start from the right-hand side and start to do the calculation there. What I suggest everyone to do is you definitely start from one side, and you work through that one side until you get to the right-hand side. The way this part here is you can put this part not on an exam paper, but as on a scrap piece of paper, so you can sort of give you some idea how do we get to that last part. All right, since we already know how do I get to the last part, I don't need that anymore. All right, so it looks like that's how we turn into the tangent. All right, now so for this part here, how do we turn it into sine and cos? Well, the first step of what you do is change that tangent square x into sine square x over cosine square x. We're sort of doing the reverse, all right, calculation. All right, so now what you need to do is times both the top by cosine square x and then denominator by cosine square x. All right, so that gives you, let's see, that gives you 2 cosine square x over cosine square x minus sine square x. Okay, all right, almost finished. All right, so now the denominator becomes, as you can see, the denominator is cosine square x minus sine square x, so that becomes cosine 2x. All right, and the numerator, I just need to do a little trick here because we know that 2 cosine square x minus 1 is equal to cosine 2x. So if we just change that into cosine 2x plus 1, we should be able to get to the answer. All right, so that gives you cosine 2x over cosine 2x plus 1 over cosine 2x. All right, so that gives you 1 plus sec 2x. Okay, so that gives you the right-hand side. It's pretty hard, all right? Pretty crazy question if you start from the left-hand side and start to deal with it. Just finish up to here, then I realize maybe it's going to be better to start from the right-hand side and then prove to the left-hand side. Well, this is the nature of a trig identities. It's always hard. I probably mentioned that before. When I was a student, I always sort of fear about a trig identity question because you just don't know where to start and which formula you're going to use. And as you can see, even for this question, I sort of need to use the right-hand side to help me to prove the left-hand side. So yeah, it's a hard question there. But again, the more you do, the more exposure that you get to the question, you should be able to, it's all about the 2 E's, exposure and experience. All right, you need to get exposed to the different type of a trig identity question, and then to get more experience, so you know when you get to those questions which method you're going to use, right? All right, okay. Should I move on to another one? Let's do another question. All right, so another trig question could be something like this. So example 2. So very similar to the one we did last time. So it's like, find the exact value of sine bracket 2 cosine inverse 6 over 7. And the question asks you to find the exact value. All right, so how do we do this? All right, the first step here, remember last time we did this before, but in terms of a compound format, this time we just let theta equals to cosine inverse 6 over 7. All right, so then we can prepare that. We get cosine theta is equal to 6 over 7. And now remember, I draw the quadrant diagram. Cosine is positive in the first and fourth quadrants. However, the range of a cosine theta is between 0 and cosine inverse. That is between 0 and 0 and 2 pi. So between 0 and, is that 0 and 2 pi? I think it's 0 and pi, yes. 0 and pi, so that gives you this quadrant and a quadrant here. So overall, obviously, the common quadrant is the first quadrant angle. All right, so that's the first quadrant angle, and then you can set up your right angle triangle because you do need that information to do the later calculation. That's equal to 7 adjacent over hypotenuse, 6 over 7. All right, so we can do the calculation, all right, to work out the next sides using Pythagoras, okay? So that gives you square root of 13. Okay, now back to this. So then we know that is equal to sine bracket 2 theta. Now do you remember that part is theta now is replaced by the theta here, all right? But you still have a 2 right in the front. All right, so that gives you 2 sine theta cosine theta, where you just apply the the double angle formula you have learned. Okay, And then we can use our triangle, so we can work out what is sine theta equals to. Sine theta is opposite over hypotenuse. So that gives you square root of 13 over 7. And cosine theta, we know that's equal to 6 over 7. So then that becomes 12 root 13 over 49. All right, so that's how you solve this question. And that's find the exact value. All right, okay, cool. Now let's move on. Probably we can try another one. All right, so how about we try a question that requires you to eliminating theta and find a parametric, eliminating theta from each of a parametric equation and to find a Cartesian equation using the double angle formula. So let's just call this as an example 3. Okay, so you have the question here says eliminate theta from each pair of parametric equations. All right, so the first one is this is the question: x is equal to 2 plus cosine theta, y is equal to cosine 2 theta. Now, how would you get rid of the theta here, all right, and then to combine these two equations, right? This is the problem. So what we need is we need to turn this one into the double angle formula, and then also we can sort of like replace this, and we can do a substitution inside. So hopefully everything is, every theta is disappeared. So starting from y equals to cosine 2 theta, I want to use one of the double angle form, but this time in terms of a cosine only, all right? Because on the for the first formula, you only have cosine, you don't have, sine theta. So that's why I just want to make sure that I use the correct double angle formula. And that's the one I need. So once you have this one here, then you can replace, let cosine theta equals to x minus 2. So that's why, we can use that formula here instead of the other two. Because I need cosine theta, so I have something to replace them. So that becomes 2 times by x minus 2 squared minus 1. All right, so the rest of the job is just factorize it, expanding and combine the like terms. X squared 4x plus 4 minus 1. So y is equal to 2x squared minus 8x plus 7. All right, that's all. So yeah, these are the 3 examples. But there are so many different examples of using double angle formula. I want to give you an opportunity to try different questions. Please remember those 3 formulas, you're going to apply that later in year 12. And in so many places, you're going to use double angle formula, even in terms of integration and differentiation. Double angle formula is so important, okay? So please, all right, you're not just learning this lesson today, and you're going to use that in the future lessons. All right, thank you, everyone.